Hey there, welcome back to another video. And in this video we are gonna make a project, very basic project using multivariate regression. And this project is basically going to predict the houses on the basis of some features of that house. So without wasting any more time, let's get into the video. Okay guys, so the first thing that we need is the data cell and data set itself. So I'm gonna use sklearn. So let's take from sklearn dot data sets import, and what we can do from sklearn dot datasets import load underscore Boston. So this is a very famous data set. Basically what you can do here is you have the data. I will just explain you what the data is in a bit. So let me first import everything from numpy as import numpy as np from matplotlib.py plot import pyplot import pyplot as plt import pandas. I don't think we are gonna use pandas, so let's just okay. Now let's read the data or read the data set. So Boston equal to load Boston. Okay, and now let's see what is the data. So Boston dot description. Okay, so this is the description basically, and let me just also print this so you will have a better idea. Print. So this is our data set basically, and we have a lot of attributes like this. These are all the attributes that we have, and this one is our output. Okay, so you will see 1 2 3 4 5 6 7 8 9 10 11 12 13. So we have x up to 13. So we have basically 13 input to predict a single output. Okay, and you can read all about this, that what attribute means what. So I'm not going to explain that. You can just read it right here. And now let's move forward. So let's take x equal to Boston dot data and y equal to Boston dot target. Okay, now we will have our x, and our x is something like this. Now let's take a look at the shape. So we have 13 attributes and we have 506 examples. Okay, and let's take a look at the y shape. As you can see here, we have 506 examples. Okay, so the next thing that we need to add our dummy variable. Okay, so but before adding that dummy variable, let me also normalize or standardize our data. So what I can do is I can take our mean. So u equal to np dot mean, and in this mean we are going to pass x, and we are gonna take the mean on the basis of the rows. Okay, now then we have our standard deviation, that is going to be np dot std and x comma axis equal to 0. Now we will have x equal to x minus u divided by standard deviation. Okay, so let's take, we have this data and we have 1 2 3 4 5 6 7 8 9. So let's suppose we have this data, so we are finding the mean. So we are, when I have passed here x is 0, so we are getting the mean of these three, then these three, and then these three. We will have some values here, some value here, some value here. So similarly we are finding the standard deviation on the basis of this data, or on the basis of rows basically, and then you can apply this formula to standardize your output. Now let's see what was the output before and the after. So our output was like something like this, and as you can see here, it is very big, or not actually very big, but yeah, you will see the difference. Okay, now let's see the data, and as you can see here, now we do not have these values, so we have changed our data very much. So now before moving on, we just have to do one more thing, and that thing is we need to add a dummy variable. So np once dot np dot once, and I have to provide the shape here. So that shape is going to be x dot shape 0 5. We have to do this because let's take 1 2 3 4 5 6, and we have to add ones, so we need 3 1, and this 3 is the x dot shape 0. Okay, and now what I'm going to do is np let's do this x equal to np dot h stack, and I'm going to add this horizontally stack ones on the x. Okay, and then let's see again x, what is x. Okay, so it is taking, oh yeah, we should provide it as a tuple. Okay, and it is, so it should be 1, I guess. Yeah, so as you can see here, now the first element in every row is 1. So this is what we wanted to do. Okay, and now let's apply our algorithm that we wrote or in the last video. So let's use this. Okay, and we want to use, let's make the epoch, let's use it 200 for right now, and what I'm going to do is error list theta equal to gradient descent, and I'm gonna pass our x and y. So it is saying that it is not meshed. Okay, so the error is that I have done this wrong, 1 and it should be working now, and we have our output. So this was the only error. Now let's take let's plot the error list so that we can see that how much error that we have decreased. So let's take plt dot plot, and let's plot error list. Okay, so as you can see here, our error has significantly decreased, and it is almost close to 0, and it is not decreasing. So I think that we should not need we can just stop our program. You can see that it is not decreasing after this point, so you can also stop your program after this point, and it is going to be very much better because it is going to consume less time. Okay, so let's predict some outputs. So let's take y pred equal to hypothesis. In this, what I'm going to do, I have to pass our x and theta. So let's take x and theta, and we are getting our output like that. So these are the outputs that we are getting. Okay, and let's also see what are the real output. So these are the real outputs, and those were the outputs that we were getting using our algorithm. Okay, so the next thing is, now let's just run this. Now our program is complete. Now you can implement it anywhere on web or anything like that, and you just have to provide some x here, and it is going to generate a value like this. So if you want only one value, so let's take only one value. Let's take the 5th example. Okay, so we have only passed one example, and it is going to predict the house, predict the price of that specific fifth house. So these were the values of that house. And now if you will use Ypred, you will see that the price is around 25,000. Okay, now the price is in thousands. Basically you should read the descriptions, and prices will be in thousands. So okay, and this is it, this is done. Now let us also see how, like how much accurate our code is. Okay, because we have to check that. So for that I am going to use R2 score. So let's make def R2 underscore score, and let's use y and y hat. Okay, now the formula for R2 score is 1 minus num divided by denominator, or you can take anything, where numerator is let me just remind me myself. So I think the numerator is sigma of y minus y predicted square, and denominator is sigma of y minus y mean. This is y mean square. I think this is the formula. Let's just implement this. So we have this. Let's take y mean is going to be np dot mean, and here we need to give our y. Okay, so let's take num equal to np dot sum. In this I need y minus y hat or y predicted value. This is our this formula. We also need to square it. The denominator is going to be np dot sum, and we need to subtract y mean from our original value. It is going to square right now, and our function is going to be, let's do output equal to 1 minus numerator divided by denominator. Okay, and now let's return output. So we have this. Now what I am going to do, let's suppose, okay, so let's suppose what we have, how are we finding our score? Basically we are passing our y, which was the original outputs, and we are passing y hat. Okay, so we are finding output of every x, so we will have y hat. And now we are going to compare them using this formula basically, and on the basis of this formula is going to generate an output from range to 0 to 100, and that number is going to be our accuracy. So let's just run this. Okay, so this is going to this. Now find R2 score, R2 underscore score. Now let's take y, and we will have our y prediction. So our model is 73% accurate, and this is not a bad accuracy for this data, because we only had 500 examples. So I think that this was our project, our small project, and you can implement this project anywhere. You can implement it on web, or you can make a software out of it. So this was it for this video, and I hope that I'll see you next time. Thanks for watching.